Today we're going to cover the last section of Chapter 17. This is Section 4, and we're going to look at sound and hearing. So the first thing we need to look at is what is a sound wave. Sound waves are longitudinal waves, and we talked about that from Section 1. They have compressions and rarefactions that travel through a medium. Now there are some specific properties of sound. It has a specific speed based on the material that it's in. It has intensity and loudness, and it also has frequency and pitch. So the speed of sound, if you are in air that is at room temperature, it's 343 meters per second. Now if the air is colder or if the air is warmer, the speed of sound will change. It will also change based on whether you are in water or some other medium. Intensity is a rate at which a wave's energy flows through a given area. So how intense something is, it depends on two things: amplitude and the distance from the source. We can measure intensity in decibels, so lowercase d, capital B. And this is just a unit that's going to compare the intensity of one sound to the intensity of another. And in your book, and this may be the wrong page number, but there is a table that actually will show you all the different decibel levels. So it starts out with something as low as a whisper and goes up to the sound of a jet engine taking off. Loudness is part of intensity. It's a physical response to the intensity of a sound. The thing about a physical response is that it's your opinion. That's how you react. So, one of you may think that something playing is extremely loud, while someone else may barely be able to hear it. So you react differently to different intensities. We already talked about frequency, so I'm not going to go into that. Pitch is the frequency of sound as you perceive it. So again, this is another opinionated or opinion-based piece here. So for all those in music, pitch is actually opinion. Now, we can use sound or sound waves in different ways. Ultrasound is one of those. So when I say ultrasound, I don't just mean ultrasound imaging. It could be sonar or anything that's using sound waves. So sonar, it's a technique to determine the distance to an object underwater. So for example, some fishermen have sonar capabilities to where that they can bounce off of and see where all the fish are under the surface of the ocean. We use it for science in the ocean to figure out how deep it is to the bottom of the ocean in certain areas. Ultrasound imaging. So pulses sent into the body to retrieve an image. This is not just for looking at pictures of babies. You can also use it to look at anything from muscles to organs in the body. Something else that we need to talk about with sound is the Doppler effect. This is not quite the same as Doppler radar. So Doppler effect is a change in sound frequency caused by the sound source moving, the listener moving, or both happening at the same time. So when I say Doppler effect, I want you to think of if you're going down the road in a vehicle with a parent or by yourself and you see or hear a police car coming toward you with siren on. As it gets closer to you, it appears to get louder and louder. Okay, the frequency is changing as it gets closer to you. Right, the frequency is increasing. But what do you notice the second it gets past you? That sound drops off considerably. So the frequency has changed at that point once it passes you until you can no longer hear it. So increases as sound approaches, decreases as it moves away. Last thing, let's talk about hearing and the ear. So this is just kind of a brief summary of how things in your ear works. So your outer ear gathers and focuses all of that sound down into the ear canal, which goes to the middle ear. The middle ear receives and amplifies that motion. So once it gets to the inner ear, it uses nerve endings to sense the motion and send signals to the brain. So you have what's called, it kind of looks like a conch shell on the very inside of your ear. That is what has your nerve endings on it. And before it can get there, the middle ear has 3 different pieces that sound has to travel through. They used to be called the hammer, the anvil, and the stirrup because that's kind of what they looked like. But now they are known as the incus, the malleus, and the stapes. So how we record sound is kind of similar, but sound is recorded by taking sound waves and converting it into an electronic signal that can be processed and stored. So what I'm doing right now, recording sound for your videos, it's taking in the sound waves from my voice, converting it into an electronic signal that the computer would recognize so that it can be processed and stored into video format. You can also reproduce that. You can also reproduce that by converting the electronic signals back into sound waves. So when you're playing a YouTube video, all of that is stored as an electronic signal. But when you hit play, your speakers of your computer or of your iPad or whatever you're using has to be able to convert that back into sound waves so that you can hear it appropriately. In music, of course, many instruments will vary in pitch by changing the frequency. Every single note on a piano or on a guitar or any musical instrument has its own frequency, and it's a combination of frequencies that give you music. Now, there is a way to have noise instead of music, and that's by combining the wrong frequencies together, because not everything sounds great when you put it together. And that's because of resonance. And that's just the response of one wave to another of the same frequency. So kind of almost like an echo. And that's it for today.